Hi, my name is Andrea China by Eurotech. We will go through this session where we will talk about something that some other people is doing during this day. So they are creating an application. You will see what is this application for, and then we will see the infrastructure behind the application. Before starting, I want to thank the Eclipse organization, IoT work group, especially Benjamin Cabet, for this booklet that they wrote autonomously on Kura, and the title is Using Eclipse Kura to Build a Smart Greenhouse. So they made a tutorial, very well done. You can find download all the resources, the code, the templates, examples, etc. So the name of this application is Shoot a Pi. Just a very small introduction. What happened in the recent times? So between the 60s and the 70s, informatics were used to computerize individual activities, and this changed the internal processes of the companies, and they started changing and their productivity, improving the productivity and changing the supply chain. Then came the 80s and 90s, and given that very many individual activities have been computerized in the former edge, then the IT companies like us started integrating this in single computerized activities. So we have had then internet technologies, internet applications, enterprise service bus, integration technologies, making these single computerized activities being interoperable and coordinated. Then came year 1020. Until this stage, until this second wave of IT-driven competition, things remain things. So changed the company organizations, the company processes, the company productivity, the supply chain, the productivity improved, but things remain things, as in the 60s. Just 4 years ago, even now, most of the things are things, but what is happening right now, starting from 2010, let's say, is that things are changing. So we have the third wave, or the first wave of the IoT. That's why we call it Internet of Things, because inside every even small thing, we are putting a PLC, a microprocessor, or even a microchip. And we all know that in a very short term, the computational capacity that will be loaded into the devices will increase. So once we will have computerized the single things, the individual things, then we will face the same kind of businesses that we had to cope with between the 80s and the 90s. So integrating what we have already computerized, that means integrating, coordinating the automated activities together with the automated things. But now, me, being a Java programmer, which is not aware of M2M and hardware management and transmission protocols and cellular communication and GPIO, whatever interfacing, what can I do? How can I work in this changing world where technologies are getting so spread, so invasive? I know Java, and I wonder if M2M and IoT are places where I can give a contribute to. Well, definitely yes, and this is something that we will see these days. Definitely yes, because now that we are talking starting from yesterday at 12 and ending tomorrow at 12, there are 4 guys here, Java programmers, that are creating a game, remote controllable via cloud. The game runs on a RaspberryPi. They have a laser pointer, and then they will use this game tomorrow morning. They will use this shooting game, remote controllable via cloud, running on Kura onto the RaspberryPi, just to see who is the most capable of reaching the targets. That is a small light sensor on the board. And they can do it in such a short term because the horizontal technology behind That means information technologies and operative technologies. Information technologies are the horizontal platforms like the cloud platform as a service, and operational technologies are instead the technologies that people doing, for instance, the maintenance of a vending machine on field use every day to perform their operations. That's why Gartner calls these operative technologies. And Kura, as a framework for the gateways, for the edge nodes, it falls under this category, operative technology. So you can have these complex platforms, technological platforms, either for information technology and for operative technology. You can have them as a commodity today. So it is like when a rich dinner for a king has been transformed in a hamburger for the McDonald's in terms of accessibility. Everyone can access these complex technologies, even newbies, even small companies with a clever idea. They don't have to have capital expenditure to start the business. They can start the business and they pay as they go. We call this process encapsulating complexity. So a Shoot a Pi is finally a collaborative hackathon, and its main purpose is to set up a shooting game remote controllable via cloud. There are 8 competitors, maximum 8 competitors. There are 4 running now. One is in trouble, already told me, because it is short in time. Each competitor designed his own app, embedded app, which is not a stupid app. It's a complex application because have a lot of business rules to be implemented inside to make the game work. And then they will use what they are doing these days to play the game, and only the first 3 will be awarded by money. Okay, there are awarding criteria. We price the technological implementations for the technical solution much more than the ability to reach the target when they play the game. They mainly use Kura with Paho, of course, as MQTT client, and on a RaspberryPi. We have provided them with a development kit. The dev kit includes the board, the cables, the sensors, a buzzer, a light sensor, and a laser pointer, and a quick guide, and of course the Kura Debian package and the workspace. And then a JavaScript dashboard, because they also have to create the dashboard, because we want to let them do an end-to-end solution. That doesn't mean only the game running on Raspberry Pi, but also the business application on the cloud, integrated with the cloud via Java, JSON, REST APIs, so that you can consume the data. And you can remote control, for instance, start and stop the game from a business application on the other part of the globe. So this game goes through 6 steps. They have to install Kura on the Raspberry Pi to set up the Wi-Fi and the I2C communication, set up the hardware, and then create their application, create their dashboard, and then have fun. From the architectural point of view, there are 3 sensors, the buzzer, the LED, and the light sensor. There is a laser pointer. The Raspberry Pi via MQTT communicates with Everywhere Cloud, that is the cloud platform made by Eurotech. It runs on Amazon servers, so on a public cloud, and via REST APIs, then they have the dashboard interface, seeing what is your score and what is your score versus the score of the other competitors. And then via WebSocket, you have the remote control of the game, so you can start and stop and send commands from your PC through the cloud up into the Raspberry Pi to your embedded application. So a real end-to-end IoT application. From the publish-subscribe mechanism, the schema is nearly this. So first of all, we have the remote commanding program, publishing the commands like start game, stop game over the cloud, and of course the Raspberry Pi with a Kura, with your embedded application they are doing, that will subscribe to the commands, so they receive the commands. Then we have the Kura and the Shoot Pi application publishing the data and the metrics that they collect when they play the game. And we have the dashboard subscribing to these data metrics, so they can visualize in real time the data when they reach here the MQTT broker, they go there. And then we have, I told you that this is not a stupid application because there's intelligence behind. Here at the edge node, they have to compute the game logic. And why did we introduce this complexity? Because it is of paramount importance, because in the Internet of Things, the edge nodes, the M2M gateways must be powerful. They must filter the data that are transmitted to the cloud. They can't transmit everything. They have to solve as much as possible in terms of business rules into the machine-to-machine communication till the sensors on a local field are communicating each other. This communication doesn't have necessarily to go through the cloud and then back to the edge node and to the other sensor. So the gateways must be powerful. And by powerful, I don't mean with powerful chipset or large memory. I do mean with a clever embedded application written on a modular software framework which is reusable and portable. Behind this architecture, there are functional building blocks, either on one side of the story, on the edge node, and on the platform, on cloud. So starting from the cloud, you see that the building blocks are not monolithic. They are, let's say, modular. You have the connection management, so the MQTT broker. You have the security module to give access to users, create the roles, the privilege, the hierarchy of clients, giving them their private view of their data and only their data and not of the others' data, because it's based on a multi-tenant capabilities. You have the data management for the telemetry data, so it's a NoSQL database for big data. It's based on an open source technology. Then we have a device management, and this is paramount importance because from the cloud you can remote control the shoot.pi application running on the RaspberryPi, and you can shut down and start up the application. You can update the application. You can do the initial provisioning of the application. You can remotely configure from the restaurant on your laptop. When you open the browser, you connect to the console. In fact, there is the user console here. You connect to a single virtual control room that is a web page. And through this console, you change the configuration parameters of your RaspberryPi and the parameters of every software layer. And the software layers on the RaspberryPi are the others one that you see. So on top of the OSGi container, we have the device abstraction layer that decouples the physical hardware, pins and ports, etc., to the above layers. And every single hardware functionality is here exposed as a Java API to the above layers. So that's why the skills that you need are those of a Java programmer, not necessarily of an embedded programmer knowing to cope with the session and with the hardware. Then the other building blocks of Kura are even here. There is an administration user interface that is exactly the same web application that you find when you connect to the cloud. So when you are local, you can connect via cable or via Wi-Fi to the local gateway, to the local RaspberryPi, and do your configuration locally. When you are remote, you can do remotely via cloud. And Kura and the Everywhere Cloud are in sync via MQTT. Then you have the gateway basic services, the networking management, so you can use it finally also like a router. That's this shoot.pi on the RaspberryPi has the routing capability, netting capability, DNS capability, firewalling capability. There are two firewalls, one at the edge node and the other one in the security layer here. So you protect it here and here. Then you have the connectivity and delivery, where you hidden the Paho MQTT client, and you manage the recovery of the session when the session gets broken. Then you have the operation and management building block that makes the shoot.pi application running on the RaspberryPi being remote controllable. So the user interface on the cloud is able to change the configuration and to send commands, also to enter in command line to this gateway, just because there are the functionalities exposed here as an API, as a Java API. And then what you really have to mind of when you have to create an embedded application like a shoot Pi is just the top of the stack. And at the top of the stack there is the application layer. So you don't have to mind about the hardware, about the connection, about the session, about the security. You just have to know about Java, and you have to code that you are reading the temperature from GPIO ping number 15, and that if temperature is higher than 15 degrees, then you want to send a message. So this is what you have to mind. All the rest of the story, from this embedded application till the business application via REST API, is given to you as a commodity. You don't have to mind. It happens. It's not it happens by magic, but it happens. I was telling you that the shoot Pi is not a trivial application. You see a sort of class diagram. So there are different classes, 1, 2, 3, 4, 5, 6, 7, 8 classes finally. This is what you can do via the console. This is just a screenshot. So this is the same console either when you are remotely on the cloud and when you are locally on the cloud. And from this console you can shut down, start up, and do whatever you have to do on the Raspberry Pi. So the real intention of this game and having fun and learning by having fun is to talk to you, to talk to the community of developers, because each of you is important in terms of contribution. We know, as we have seen in the former 4 slides, that Internet of Things is changing things, and then the way things will interoperate with activities that we already have computerized mean that we are changing the remaining 80% of the global business. Yesterday we learned by the keynote that until now we, software developers, have addressed just 20% until now of the global business. There is still an 80% related to concrete things which is not yet reached by us, but here things are changing. By the mean that we are changing things. Things are becoming intelligent, and so this is a new space for us, for programmers. And so be part of Kura, join Kura and contribute. Special thanks to Eclipse Foundation, to the guys that made Kura, and the guys of Beard by Actuate that are creating that created the dashboard based on the REST API interfaces. Thank you. So if there is any question, I'm here.
You said from the backend you can also update the software on the Pi.
Yes.
And assuming that you, considering the fact that you have MQTT connection between the backend and the Pi, so you will be sending probably the binary data on MQTT?
No, we send a message via MQTT where we inform Kura. Wait, I go back to Kura. So when you change a configuration on this side, a message is sent to Kura, is interpreted by Kura, and the configuration is applied through an API Java class running here and made available via that API to your application, for instance, which is consuming that API. And that's why it appears, and vice versa. If you change a configuration here, it is sent. It's based on a publish subscribe. It's based on publish subscribe. So the cloud becomes subscriber of that API, that is a service finally, that sends the change configuration information and apply the change configuration on the cloud.
But if you then want to install a new bundle or a new version of the bundle,
exactly.
you transfer to Pi somehow.
Exactly.
Does that occur in-band or out-of-band? That's the question, I think.
If it is,
I was assuming that you also send the application, for example, from the backend via MQTT onto the Pi.
yes, correct. So this is an outbound message from the cloud.
Not the message. I think I'm assuming your message is there is a new version of this bundle.
There is a new version, and because yes, you're right. Kura subscribes to the service provided by the cloud, which delivers the new updates. Okay. Then there's also a scheduler that programs this. You can also schedule this activity. But from this point of view, yes, you're definitely right. So it is a subscriber that receives the update that is published by the cloud.
But the binary itself is not transmitted using MQTT, but by a separate download by means of HTTP, for example. How does it work?
No, it goes through. No, I think it goes through MQTT. Also the file. Also the file. No, I would say that I'm not 100% sure, but I would say 90% I'm sure of what I'm saying, because we never have to open a different port. So we always open on that side the firewall, the port of the MQTT, and only that. So I'm confident that every bits and bytes go through the MQTT, but I'm not 100% sure. I will have to check it.
Contributions that Kura made, because originally the OSGi bundle update was done over HTTP. So even if you got your notification through MQTT, there was a new bundle waiting, you had to go out over HTTP to go and get it, which, as you say, means you have to open another firewall port and all the security issues. So by rewriting the bundle load of thingy in OSGi to use MQTT instead of HTTP, they kind of got around that problem for delivering those bundles over.
Thank you. Yes?
How does this device management go? So until or to which layer you can update your software? So is it possible, for example, to change the Java VM that is
Yeah.
on that machine?
Yes, because we do the initial provisioning of the system. And by the initial provisioning, we start, I'm sure that we start from the OSGi. I'm not sure if I know that if I connect to the console, I could connect here, but I don't know. I do see what version of the Linux is. I do see what version of the BIOS is that is running over there. I'm not sure that I can change the BIOS and the Linux, but I'm sure that I can start from the OSGi on top.
Do you use any standard means for managing the resources of the OSGi container? For example, do you use something like a device management tree? Do you know that?
Don't know.
Do you have some native component in the Gateway? Watchdog component?
Yes, they are. Yes.
It's not 100% pure Java implementation. It's just some
Yeah, we do have the watchdog interface in the device abstraction layer that is inherited by the layer below. But we do have the API on top of the watchdog service, as well as the other security services provided by the VM or by the operating system, also by the Linux operating system.
This is not in your...
No, because they must be exploded. I should drill down. I have another picture, not in this way, but that drills down and gives you the atomic building blocks of this main level functional blocks that are represented here. For instance, in the networking, we have the firewalling, NATing, DNS, some other. Okay. So, thank you very much. Yeah, yes?
So are you using individual topics for each and every Pi that is connected to the backend?
You mean for each individual Pi? You mean for each individual?
For each and
every single gateway.
Yeah.
Now, topics, let's say, are not bundled to the gateway. Topics are you can have the same topic on different gateways.
Yeah, you can, but do you want to? Because I mean, the
but they are related to they are linked to a device ID, to a unique device ID.
Yeah. But the other way around, for example, if you want to send a command to an individual gateway, a reconfiguration command,
Yeah.
you want to make sure that it can be only received or is only targeted at a single gateway, right?
Yes. In fact, this unique ID is one of the services provided on top. A typical example is the USB. Each time you connect and you unplug and replug the USB, changes the physical ID at the operating system level. And here we do have a mechanism to preserve that ID forever for that single individual gateway.
I'm referring to the MQTT connection infrastructure between your backend and the gateway. So for the direction from the backend to the gateway, does the backend publish to an individual topic for each and every gateway, or does it publish to one topic, received, subscribed to by all gateways, and then the gateways simply read what is intended for them?
Yes. No, the latter, the second one.
Latter.
Yeah.
You can target a command to a specific gateway. It has a unique ID in the topic, but there are also some broadcast topics which everyone listens to.
Yes.
Or everybody shut down, or everybody go
Mm-hmm.
So if you then have individual topics for each and every gateway, does that actually present a problem to the MQTT infrastructure once you increase the number of gateways? I mean, if you have 100
No,
gateways,
in my knowledge, no. There is not a limitation of this way, in my knowledge.
Do you have to use some special sensors that are recognized by this architecture, or you can take any sensor and plug into this RaspberryPi?
Yes, theoretically, yes. Then it depends the sensor how transmits the data, how the sensor transmits the data. If this sensor would use a transmission protocol that is not yet supported, then you have to add a new field protocol to. But if it is used standard serial or Ethernet or Wi-Fi, then yes, it does. In fact, there are some proprietary protocols that are not on Kura but we had to implement them to connect vending machines or fitness machines. No, it's also difficult to do then, you know. It's an isolated problem. It's an isolated problem. You don't have to touch the rest of the architecture, you just have to add some logic in a new library, a new bundle file in the tree of the field protocols. You have to understand the specification, to write it, to test it. But it's very isolated intervention, let's say.
Here it looks like that this application simply needs to deploy a bundle on the left side, that the data is somehow stored also on the right side. Because the Raspberry sends some data which applies to this game that you have deployed. And how is this data persisted into the database?
Okay.
Do you have defined a generic forward as an MQTT message back from the device to the management platform, which then, depending on the topic name, for example, persisted to the database in a predefined format, or else I would assume that there are also some application parts have to be deployed on this management platform.
Okay, so the persistency is we have a database either in the Kura, so the gateway side, and in the cloud. There are two different technologies for two different purposes. To store also in the long term the telemetry data, which are published and on a topic, a hierarchical topic with a key value pair, then they are stored once they arrive here into a database here. This is the Cassandra database in this case. Okay, and they are stored over there. So it's a NoSQL database. Then there is a MySQL also over there to store the attributes of the device birthday, device death date, the device ID, and the GPS positioning, the users. And here are manage the persistency of data at the cloud. But on the gateway, there's a in-memory database that can store on the file system of Linux, the data retrieved by the sensors connected to the gateway for a certain period of time. And you can define the rules if it is cyclical or if it is just for a limited period or until the connection is with the cloud is restored or recovered or active, so that you can have a local cache. And this is not only to caching data, but it's also to empower the capacity of the gateway in terms to solve local business rules accessing to local data.
The answer you gave in between was you have a key value format for the data that's transferred to the management platform. So you define, when you utilize this kind of blueprint, let's say it that way, that you define that your MQTT message consists of key value pairs, that you are able to persist it.
Yes.
Yeah, which is not mandatory, so you apply some...
Let's say that it's payload agnostic, because we take what we get from the sensors. Yeah. We know the topic, so we send the topic and then the value of the key value information. They are sent, serialized, the message is serialized, sent to the broker, and then deserialized on the other, on the cloud side, and then stored as a key value pair into the database. Maybe I didn't get the question.
How do you know that the MQTT payload is the key value, the set of key value pairs? You have to have some assumptions how the data looks like. If you would persist it in a relational database, you have to break it up in columns and rows. So how would you do that if you don't know anything about the format? So just taking the data as it enters, you could only say, okay, I perceive this topic and the blob of data. But how can you run an analysis?
Well, there's an analyzer, but on the server side, where there is a business rule engine that inspects the messaging, the incoming messages, and analyze the data, and can invoke a rule, and according to the rule can decide if sending a message via SMS, via Twitter, via MQTT again, or via REST API, and then the message is stored and persisted. So I don't know exactly the mechanism how it works, but I know that there is a real-time inspection of data brought through the MQTT message, via the MQTT message. But I apologize, but I don't know how this mechanism works to explain you technically how it works.
Can I say something? Generally, the MQTT, you don't know the format of payment, but it's the design of the application to say you have an application sender, an application receiver, and they understand the messages between each other. Yeah. So you're sending the topic on the clue.
Yeah, I completely agree on that, but it looks like that if you want to follow that approach, I completely agree to what you said, but looking at that picture, I look that you only have on the left side shoot a Pi, which looks to me like the application, but nothing on the right side. How can you persist data in an analyzable format if you don't know anything about it?
So in some cases, for example, if you know to read JSON format, you could dump it into Mongo and say that it's or XML database, or database,
but then
store it as is.
Exactly, but then you have to have somehow a contract.
Right.
And it doesn't look to me like that the right side has any means of what is coming from the left side, which doesn't look like the real case. For that purpose, it must be something.
But listen, there's a colleague of mine who is a developer. Maybe on the booth where we are at the playground area near the theater, maybe he can give you this answer, okay? Because I'm the marketing program manager, so I don't know everything is of the internal, so I really apologize. But I didn't make it, so I'm really sorry that I didn't make it because I love it, but thank you.